to solve another Leetcode problem 23, 28, number of increasing paths in a grid. So for this problem, actually, we are just calculating how many increasing paths in a grid. So this increasing path must be different for each of them. But we can also choose one cell. So for example, the numbers like 1, 1, 3, 3, and 4, this is also possible. And for others like 1, 2, 3, 1, 2, 4, 3, 2, 4, and the last one going to be 1, 2, 3, and 2, 4. This is going to be the last path. So in total, it's going to be 8. So this is going to be the problem. Yeah, so for solving such kind of problem, we're going to check if we can solve it by using DP. So basically, we're going to use the DFS plus memorization. So for example, inside this grid, we have the values like 1, 1, 3, and 4. Now, what are we going to do? We're going to check each of the cell from the left to the right, from the top to the bottom. So we're going to check one by one. So for this one, we're going to check how many. So from this position, at this position, this is our starting point. We're going to check how many of them. So itself, it is 1. So it is 1 path, because for this value 1 itself, it is 1. And then we're going to go to the left side. 1 equal to 1, it is not possible. And then we're going to go to the bottom side. Yeah. So if we go to the bottom side, we're going to check how many paths for this, if we're starting from this one. So for so we're going to check how many of them if we go to the bottom. So it can be a 1, 3, or it can be a 1, 3, and 4. So how many of them? So it's going to be 2. So 1 plus 2, it's going to be 3. So this means if we are starting from this position, it's going to be 3 paths. It's going to be 1, 1, 3, 1, 3, and 4. And similarly, we're going to start from this position. So it's going to be a 1, 1 to 4. It only has 1 to 4 because it can never go to 3 because 3 is smaller than 4. And also we can start from this number 3. So it can be a 3 or it can be a 3 to 4. And lastly, we can start from this number 4. So it can only be a 4. So how many of them? 3 plus 2 plus 2 plus 1. So it's going to be 8. So this is the idea. Maybe you're going to think, will this cause time limit exceeded? It will not, because we're gonna use a case. So this means the sum of the cell while we are calculating this one, actually for this 3 and 4, it has already been calculated. So for the next time, it's gonna be just O1. So in total, the time complexity gonna be OM times N. That is why it is so fast, because there's no actual calculations. We put everything inside this case. So for example, for this number 3, for this number 4, if we are calculating 1, 3, 4, actually, for this 3 and 4, it has already been calculated for us. So for the next running, it's going to only be O1 instead of OM times N. So the total time complexity is going to be OMN. Yeah. Now let's just try to solve it. Let's do some preparations. Normally for such kind of problem, I'm going to use R and C as the length of the grid and length of the grid 0. And I'm going to prepare a directions array. So it's going to be 0, 1, 0, minus 1, 1, 0, and minus 1, 0. So this is just for directions. And I also need to prepare a final result to record what is going to be, my final return. There is also a mod, so let me just prepare a mod. Normally, it's going to be 10 to the power of 9 plus 7. Now we want to check the final result. So for R in range, capital R, and for C in range, capital C, we're going to plus equal to the DFS. So it's going to be R and C. Finally, we're going to return result modular the mod. Now let's just write the DFS, but before that we're going to use a class. So we are going to check how many paths. So from the beginning, whether we can go to the 4 directions or not, definitely we're going to have a path of 1, because itself is going to be a path. Yeah. Now we are going to check the 4 directions. So for DR, DC, inside the directions, we're going to update the row and column. It's going to be R plus DR and C plus DC. And then we're going to check if it is inside the boundary or not. Yeah. So if it is inside the boundary, and also it's gonna be the grid, not matrix. Yeah, and also the grid R and C less than grid this row and column. Yeah. So this means it is increasing path, so we're gonna accumulate the value. Yeah. So result gonna plus equal to this DFS. It's gonna be this row and column. So finally, we're gonna return this result. Maybe we're gonna use a result modular mod just to increase the speed a little bit, maybe. I think that's all for it. It's not a too difficult problem. So the idea is that we need to understand how to calculate the time complexity. Actually, it's going to be m times n. So it's going to be 10 to the power 5 for the final time complexity. Yeah, I'm not sure. Let's just run it. It seems it works. Now let me just submit it. Yeah, as you can see, it's pretty fast. It is like less than 1 seconds, and it is okay. Now let's just try. If we delete this mod, I think the speed will be slow. Let's just have a check. Yeah, if I delete this mod, I think it's gonna be slow because the calculation for big numbers. Yeah, it slows a little bit, but it is okay. Normally we're gonna prepare a result modular mod, even though finally we're gonna prepare this result modular mod, but yeah, we just reduce the big numbers calculation for the plus calculation. Even it is has little influence, but that is okay. We had better, yeah, to put a mod, even though there's no influence for the final result, but it's gonna influence the speed a little bit. I think that's all for it for this problem. Thank you for watching. See you next time.